Sir,
this
your
thing.
presentation not visible.
Yeah, I've already said it's not visible.
It is
Yes,
visible, sir.
Visible.
Visible, sir. Visible.
Visible. Okay. 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 So let us try to understand these things. Basically, this star 256. Star means what? This is secure. This is being called a secure hash algorithm. I think we have seen this one. Okay, one. Let me check it further. We have seen this thing basically. Okay, and we have illustrated this one, this hash function in the previous class. This through this website. Why we are going to discuss this star 256? Because this is going to be used in Bitcoin. This one is going to be used in Bitcoin. So basically, star 256 is a hashing algorithm. This is what? This is a hashing algorithm, and the full form of this is secure hash algorithm 256. What 256 represents? It just represents the. Oh, I think you need a recording as well, na? I need to just on the recording so that you can get it. Let me check.
Hello.
Yes,
Sir, actually, na, these recorded lectures are not accessible by us.
I need to share it to you
Uh,
with you, na? Okay, I will try to share
Sir,
it. Okay.
actually, the last lecture you recorded, na, it is not opening actually. It's showing some error that we don't have access. I think it would open only IIT Patna, only something like
Oh,
that.
okay.
Yes. Because last recording is available, but we are opening it and it is not. Oh, it is not opening. It is showing some error.
Okay, got it.
Yes, sir.
So
But
let
is
me
there
check it.
any other way? Yes,
Let,
yes,
let me check
yes.
it first. Let me check it first. Okay. Mm, This SAR 256, the hash algorithm, basically cryptographic hash algorithm is there. Like SAR1 is there, SAR2 is there, MD5 is there, SAR 256 is there, SAR 512 is also there. So many such type of algorithm is there, but the SAR 256 is being used in the blockchain by the Satoshi Nakamoto. So we'll try to understand what this SAR 256 is. Okay. So this algorithm is basically going to take a message of any length. What I'm telling, a message of any length, and it is going to produce. It is basically going to produce a 256 bit message. What I'm telling, what is the hash function? Hash function can take any value, okay, and it is going to produce it. It is going to output a fixed length message. So similarly, it is going to give you the 256 bit message digest. Now it is a part of SAR2. Okay, it is a set of cryptographic hash functions designed by United States National Security Agency. So yes, US US NSA has basically designed this cryptographic hash function for some security purpose. Now, what is the pre-processing of this algorithm basically? If you try to see it here, what is the pre-processing of this algorithm? Let us see it here. So it is saying that pad the message such as the message size is multiple of 512. What do you need to do? Let us think you have taken a message M, which is being applied by the hash function. So what I'm telling basically, you need to apply a hash function on a message M, and you don't know what is the size of this message. Okay, this message may be very, very long. So what you need to do, you need to make the size of this message in a multiple of 512 by padding some bits. Okay, let us call it the message is a very long. Okay, so what you will do, you will just divide the message by 512 and you see that how many blocks of 512 is there, and after that how many bits are remaining. Okay, and you have to pad some extra bits there so that it will be the multiple of 512. Let us call it the last bit, at the last block there is only 500 bits. Okay, now you need to pad 12 more bits there. So like that. So here it is supposing that the length of the message is L. We are going to suppose that length of the message is L. Okay. So L mod 512 will not be equal to 0. This is mod operation which is going to provide you the remainder. What you need to do? You need to first append one bit at the end of the message. Whatever message you have to append one. Now append k0 bits where k is the smallest non-negative solution to the equation this. What you need to do? This is the message length. This is what? This is actually length of the message. Okay. You are going to add 1 to it, and after that you are going to add k bit 0, k0 bits, which is nothing but equal to the 448. Mod 512 means if you divide this number L plus 1 plus k with the 512, it is going to give you 448. Now, since this is the 448, so if you try to find 0 mod 512, what you need to do actually, this is 448. If you add 64 to it, it will become the 512 and you will get the 0 value here. So that's why you need to append the 64-bit block which is equal to the number n written in binary. Got it? Got it? What is the 64-bit number? You need to add the 64-bit so that it will become a 512-bit number. Okay. What is the 64-bit block? 64-bit block will be the binary value of L. And what is the L? L is the message size. Now, if you divide this all, please mute yourself. The total length get divisible by 512. Now what you need to do? You partition the message into n 512 blocks. A message is very big. This is the message. Message is very big. This message is going to have many blocks of 512 after appending some bits. Many blocks, okay? This is a 512 bit. This is a 512 bit. This is a 512 bit. Because we have already padded something so that this will happen. Now let us call these 512 bits are, we're calling it M1, M2 and up to the mn. So there are, let us suppose there are n such blocks which is going to have 512 bits. Now this every 512 bit block is further divided into 32-bit sub blocks. So what do you mean by this? This 512 bits, every 512 bits are going to be divisible by 32-bit number. How many such numbers will be, how many such divide will be there? There will be 16 such subdivision. So for every this one, for every m, you are going to get m0, m1 up to dot dot m15. Kindly mute yourself, man. Okay. So these are the things till here. Now let us try it's not moving. Now this is okay. Now the message block are processed one at a time. Every block is going to be processed one at a time, and this is going to be start with H0 as value 0. What is? Let us try to see it here. So if you try to see it here, see this. See this. This Hi is going to tell that this is Hi minus 1 plus compression function on this m of I. How many m I are there? Because we have m of 1 up to dot dot m of n. So total number of blocks, 512 blocks are mn, and this one. So why you need to take this H0 as the initial hash value? You need to choose it randomly. Well, because if you compute this one, let us call it H1. So this will be nothing but I minus 1 means 1 minus 1. Then you will get the 0 value. So that we need to have this H0 for computing the successive hash function. Okay. This C is the STAR256 compression function, and this plus, whatever the operation plus is there, this means it is going to add the mod 2 to the power 32-bit addition. And the last hash, whatever you get at the last, whatever you are going to get at the last, this will be the our output. This will be the our output. We are going to get this output. What it means basically, what it means, if you try to see it, a message M is given to you. You need to do something on this message. Let us call the message size is L. Message size is L bits. Okay, or okay, this is L bits. Now you make this message in a multiple of 512. Okay, blocks of 512. So this is the first block. This is the second block. Let us call it. This is the nth block. Okay, this is the nth block. Okay, if something where you are going to pad something has been padded because of it is not of 512 bit. Okay, so every such block are further going to divide it into 16 32-bit number. Every block is going to divide it into like that, and we have already chosen one initial value of H0, and we are going to take this one plus this one into this one. Okay. So in this manner, we are getting all these terms. Now, sit here, try to go further. This will be the simple diagram. In every M0, at every M0, what is M0 basically? It is a 512-bit block. 512 bit ka block hai, which is further divided by into 32-bit number. So This is the initial vector which we have taken as H0. Okay. And after n such iterations, we are going to form the message digest. Now, what are the different patterns a hash function is going to have? What are the different patterns a hash function is going to have? So there are these 5 different patterns of hash values. One is independent hashing, another is repeated, combined, sequential, and hierarchical. So what do you mean by these all hash functions? Let us try to see it here. Independent hashing is telling that if you have something to be getting hashed, so let us call we have a hash, so hello and word. So this hello word, these two terms are independently hashed. What we are using? We are using a 256-bit hash function, okay, SHA1. Let us try to understand this. Let us try to understand this. So this website, we have already seen this website when we have gone for something. What I'm telling, so my message is what? My message is hello in an independent hashing. My message is hello, hello, hello. Type it hello here, hello. And if you try to calculate the hash function, my this SHA-256 SHA-256 algorithm is going to produce this as output. But if you try to see it in my slide, we are going to take only first 8 bit of only first 8 digits of this particular hash function. Let us try to see it here. This is 185F8DV3. Similarly, you can see it here. Okay. How did you get it? How did you get it? How the software is going to get it? For hello world, we have taken this 8-bit number. So we try to see it here in supplementary material. We are using hash function. If you try to use hashing, if you try to use hashing of same message hello, hello, what we are going to get? This is only 8-bit number. What is this? These are the hexadecimal values, okay? I think you all know the hexadecimal values, yeah? This one bit is going to have 4 bits. This one, every bit is going to have the 4-bit number. Is there any problem?
No, sir. Okay.
Good. Now, similarly, if you try to see this the word, this is a word. If you try to have this word an explanatory mark, word an explanatory mark, what you are going to get? You are going to get 514 B6 BB7. Similar. This is the similar. So if you have a message like this, and if you are going to concatenate it, okay, this will be the repeated hashing. Or anyway, not actually. I just tell it wrongly. If you have any message, if you want repeated hashing, what it means basically, if you need to take this message and you are going to get the hash of it. What is the hash of it? There are two things. In the supplementary material, there is hash function. It is going to give you the exact hash function. And hashing is going to give you the first 8 digit of the hash function. So let us have this message. It's hello world. Okay. And if you are going to get its calculate hash value, 8-bit hash value, 8-digit hash value, not bit actually. So we are going to get 7F and something. this value will be appeared here. Now what? If you try to see, I copied it here. As I repeated, I found the hash value of hello world explanatory mark as this. Now I'm copying it here and putting it as the input. And again, I'm going to calculate the hash value. What do you get actually? 45 something. 45A 497 something. Are you getting this point? Okay. So this is the repeated hashing. Now, this is a combined hashing. What is this? This is the independent and again repeated, and this is the combined. This is the combined hashing. Okay. You need to combine these both the values and you are going to get something. Okay. Like hello is here and word is here. Just combine it. Like this. Hello is a different term and word explanatory mark is a different term. If you try to see its hash value, this is 7F83. Correct, 783. This is the value. Now what do you mean by sequential hashing? You will first get the hash value of hello and whatever will you found, you will concatenate this value with the next word, and then if you get some hash value, it will be working like that. How it is going to work? So this is nothing but if you try to find the hash value of hello, it will going to give you 185F 8dB3. मिला लीजिए 185, very correct. Now we are going to combine this hash value with word explanatory mark. I'm copying this value. I'm copying this value and now putting it here, WORLD word explanatory mark, and I'm coming with this one. Now if you try to find, it will be like that. 5795 कुछ गड़बड़ हो रहा है 59 क्या हो रहा है ये दिस इज इसमें गड़बड़ हुआ है 5975 दिस इज द वैल्यू 5947 ओके 5947 is the value गड़बड़ हुआ है yeah this value okay so 579 आ गया अब ठीक है कॉन्कैटिनेट किया एक स्पेस का दिक्कत था स्पेस देने पे आ गया वो नो इशू. Now this is a sequential hashing, and after that we are going to get this hierarchical hashing. What we are going to do? We are going to find the hash value of hello. We are separately going to find the hash value of word. If this both is there, now we are going to concatenate this value, and whatever the hash is, we are going to put it here. So this is the hierarchical hashing. So why we are studying these all these type of hashing functions? Because the combination is going to be used in the blockchain or you can say in Bitcoin, okay, for securing the blockchain network. Okay, so if there is some problem. There is some problem with the direct hashing, whatever we were calling it, independent hashing, where every message is being independently hashed. So instead of providing this independent hashing, if you go with this hierarchical hashing, it will provide more security. Okay. So let us have the topic of interest, that is a hash pointer. In the starting classes, we have discussed that all the blocks are basically connected through a pointer like linked list. If you study the linked list where actually memory pointers are there, but in case of blockchain, we are going to have this hash pointer. What do you mean hash pointer? It is not basically hash pointer, it is a cryptographic hash pointer, call it hash references as well. It is a pointer to a location where some information is being stored. Obviously, It is a pointer where something is being stored. Obviously, it will be the matter. Why we have the pointer? Why we have the pointer? If you are going to have the linked list, if you are going to have the linked list, what we will have? This is like this. This is the linked list. And we are calling this arrow as a pointer. Arrow as a pointer. Okay. And we are going to have some value here. Let us call 7 and let us call 5. Okay. And up to dot dot. Now these pointers are memory pointers because some memory location is being stored here. What it means basically, let us call, this is our memory, We are going to put 7 comma something. Let us call it 100. But it means 7 comma 100. It means first value is 7. This is something. First value is 7. And the second value we will get at location 100. Let us call, this is the location 100 in the memory. And where we are going to get 5 and the pointer to the next value. So here the pointers are nothing but the memory locations. क्या है ये memory है. This is the memory location, memory value. Okay, the memory references. Now in this case, this hash pointer is basically not looks like the memory references. It is something different. This hash references something different. What a pointer represents, obviously it is some information stored. This is okay. Now, hash of the information is stored. What is being stored? Hash of the information is stored. What it means? Let us we have a block in the blockchain. Okay. And this is the next block we have the blockchain. So this block is going to point this block through some hash function.
Sir, drawings are not visible, sir.
Not visible.
Yes, sir.
It is visible in computer, not in mobile.
Okay, you are seeing in mobile. It will be very difficult.
I mean both.
Sir, even
I
in
mean
computer also
both.
not visible, sir. I'm
It is
unable
visible, sir.
to.
Okay,
It
no
is
issue.
visible,
I
sir,
will
clearly visible.
draw it again.
Yes.
No issue. No.
Sir, it is visible
Sir,
in my computer, but not visible in mobile.
Mobile में तो नहीं होगा, obviously. Okay, let us try to understand this thing. Hash pointer. Let us grab. We have a block. This block is there, and there is another block in a blockchain. Let us call it there. So, what will be hash pointer? This first block is basically linked with the second block. And how it is linked, we will see it. This pointer is being called as hash pointer. This pointer is basically called as hash pointer. Okay. And how it is hash function? What we are going to do? See, it's very simple. Here in the block itself, let us call it. This block is going to have a value m. Transaction m. What is the information being stored in the first block? Let us call it m. So its function is basically stored here. Since the hash of m is being stored here, I can directly reach from this hash to my previous block. This is the hash pointer. So what can you do with this hash pointer? With the hash pointer, we can just retrieve the information. Obviously, if we are at block number 2, let us call this block number 2, let's call it block number 2. If you are here at block number 2 and I want to just see the previous block value, I can go with this hash pointer. Okay? So check that information has not been modified. This is very important thing. We're always saying that if you're using the blockchain, we can only append in the blockchain. We did not delete or modify the content in the blockchain. Why it is? Let us think. This is the message stored here, and this is the hash pointer. So this HM we are going to link this M. Now let us check it here. I'm going to change this message M from M to M dash. I did change I changed this message from M to M dash. Okay. Since hash of M and hash of M dash are not similar. We have already seen that these are not similar due to the property of collision resistance or collision free property. If I change this message, it must be appeared here as well as because it's a hash pointer. If I'm going to change this message, what is the problem here? If I will change this message here, the link will be broken. Why it is? Because in the next block, I have stored HM, not HM dash. Okay. So by computing the message digest, what is this? This is being called as message digest. If you find the hash function, this is being message digest. By computing the message digest, then matching the digest with the stored hash value. What we are doing, how we are guaranteeing that in blockchain we cannot change the block. Since my message is previous block message is M, okay, and I have stored HM in the next block, in the header of next block, okay, in the header of next block, and it is being linked. If something is being changed here, how can I verify it? I can verify it very easily because if I found HM here, it will be matched with this value, obviously. And if I'm going to change this message to M to M dash, this will be nothing but HM dash, and then this will be not equal. This will be not equal to each other. In this manner, we can say that we can just go with the message digest, okay, and we can have these things. Let us see the next slide. It will be very much clear. This is the hash point. So this is the hash function. My data is here, means my block is here, and I have stored the hash of this data somewhere else. So the hash pointer. If something is being changed here, okay, if somebody made some changes here, it will be caught. Why it is be caught? Let us call it. This is the data. Let us call data as M. Okay, I stored this data into somewhere else, HM. Okay. Why I have stored it here? Because if somebody is going to change this message, I can easily verify. How can I verify actually? If somebody changes this message from M to M dash, I'm going to compute the HM dash, and clearly this HM dash will be different from this HM, stored HM. So if this calculated HM dash is not equal to HM, we can say that yeah, there is a modification in data and we are not going to accept this data as there is a modification. It is very simple. If you have some data and you just want that this data cannot be modified in future by somebody else, what you will do? You take this data, find the hash value. How can you find the hash value? Using the any hashing algorithm, okay, like SHA 256. And you store that hash function somewhere else. What is the size of what is the output size of hash 256? The output size is 256 bit. It is going to take any length message and it is going to produce 256 bit number, that is a message digest. Okay. Now, how we are going to detect the temper using the hash point? I just dictate it here. Let us call this is the message, hello word explanatory mark, and I have taken the hash function of this and I stored it here. What I did, hello word is there with explanatory mark, and I have stored its hash value as R1. Now in the next sub figure, what I'm going to do, I change the message from hello world exclamatory mark to the hello world question mark. I just change this message. As soon as I will change this message, the link will be broken. Why it is being broken? Because this R1 tells that, okay, I am the hash value of hello world exclamatory mark. But when I am going to change this explanatory mark to the question mark, the link will be broken because this R1 is not going to match with the hash value of hello world explanatory mark. So if some attacker try to modify this number, this value, obviously the stored hash value is not going to be matched. Okay. Okay. So what can the attacker do next? After changing this value, what he is going to do, he also change the hash value as well. Are you getting a point? You need to just change the message, and after changing the message, you need to compute the hash of this hello world, exclamatory mark, and you get something. So this is going to be stored here. So this is the gray color R1 and this is the black color R1. These are both are different. So the attacker is very clever. If attacker is going to change the message, he will be caught that yeah, he changed the message. Everybody can just verify the hash with the R1 and it is getting wrong. Now what if he changed the message as well as he changed the hash pointer as well? So in this case, he is not going to be caught. What is the analogy in the real life? I'm going to relate with the real life examples. So let us see if you go in the library of your university and if you have a backpack, okay, if you put this backpack in a, give your backpack to the security guard and he is going to give you some tokens like R1 and you put your he puts your bag into a particular space, some box, okay. Now if you come and if you show this token, your bag will be returned. What if somebody changes your bag? Like if you have the backpack and he just change your backpack with a handbag or hand purse. So since that token is for the backpack and it is being changed. So this is the scenario here. You can relate it with the real world example. Any problem, any question, you can just ask. कोई समस्या है बताइए. We will have a 2-3 minute break.
Sir, I do have one doubt, sir.
हाँ बोलिए.
Sir, in real life, can we change the both hash and this message?
Yeah, this one, this will be appeared.
The last case, sir. The last
Yeah,
case. The last
Yeah,
case.
yes. If whatever token is there, okay, from you, if you are sitting in the library and if you someone stole your token and put another token in your packet, okay.
Okay.
Now the guard which is sitting there, it will be clearly seen that the guard will tell that no, it's your bag itself because token has been changed.
Okay, sir.
Okay. Okay.
But in real life, the token also we can change. That means the hash number also we can change.
Yeah. So if you're going to change the hash value, if you're changing the hash value, there is no problem. If somebody modifies it, yeah, it will say that whatever the value is stored there, hash value is stored there, it is matching with the hello world question mark. So there is no problem. So how to avoid this type of things? If the attacker is so powerful, he can just change the message as well as your message digest. Then there is a problem with your algorithm. Okay, everything is in control of attacker. We will see it later. What actually is there? Okay.
Okay, sir.
Any other question? Any other related question? No question. Okay. Abhijit ji, yes.
Sir, this code is always fixed for a particular function or word.
Sorry, what you are telling?
This code is always fixed for a function or word.
Which code?
Whatever
Which
code is this number, whatever generated, it is always fixed.
Yes. We have all discussed that
And-
if you are going to have a hash function, hash value, it will be always going to create the same hash value for the same message again and again.
And
Let us
for a
let us
combination,
try to see it here. Let us try to see
yes,
it here.
we see it here.
Yeah, let us call it word. It is going to generate this hash value. Okay, in the first time, I'm going to clear it again, and I'm going to write word exclamation mark again. So it is going to produce the same output. But
And a combination of word, whatever the code will be generated, how it is generate that code, what is the process behind this code generation?
yeah, that I told you just before. This is the algorithm involved here. Algorithms I just taught with you guys. This hash algorithm. Okay, a message is taken and is going to produce a 256-bit hash value. This HN is the output. What is your input? Input is the message whose size is, let us call L. And what is the output? And output is the H of N, last hash value. And this is the iterative function. कई काम एक साथ हो रहा है, मतलब firstly you need to input something and you are going to call this value M0 with C is a comparison function, and again this M0 with C, okay, n time, and at the last you are going to get the message digest. So by this algorithm we are getting the thing. Okay.
Okay.
So let us have a 5-minute break here, and after that 4-5 will appear again.
Okay, sir. Thank you.
Are you here?
Yes, sir.
Yes, sir. Yes.
Yes, sir. We are
Okay.
there, sir.
Okay. So this we have to think about. Now let us have this discussion. Making tempering hash chain. Okay. computationally challenging. So how we can avoid whatever you have previously? What is the problem here? If somebody is going to change the message, okay, and if he can change the hash value as well, it is very it is very attackful actually. The attacker can do it. But if you try to introduce something called some knowns with the hash value, what it means, along with the data, data itself, data D, let us call data D, and we are going to concatenate some knowns. What is that known? Knowns is some value 0, 1, 2, 3, 4, 5, 6. Okay? Knowns is of any value. So let us try to see what is the restriction here. If you try to do it, now the hash value is this. Now the hash value is this. So if I have data, if I am going to compute its hash value and it is being put somewhere else, it is difficult to be prevented. Now try to add something to the data and we are going to put its hash value. This will be somewhat good. How can you claim it? Try to claim it first. What do you mean by computationally challenging here? Let us try to see it. So this website, see this is our website, and let us take this word, hello world. Let's try to see it. Hello world, and let us call it, let us add some known 0 here. We are going to get 4EE 4B774. Let us match it. 4EE, same value, this value. How did we get this value? How did we get this value? Again, I am repeating, please see it carefully. In the supplementary material part, hash functions are there, and I am going to write hello world with unknowns 0. I will get different type of MD5 values. It is MD5, it is star1, it is star256, it is star252. What is this? What these are? These are nothing but the hash cryptographic hash algorithm. They have a process to compute the hash function, as we have already seen this star256 algorithm. We have just seen the working of 256. In the similar manner, MD5 is also having some working property, working steps, star1 as well, and star256 5.2 is as well. Now if you try to note it down, this is nothing but 4EE4B774. This is the value. First 8 digit which is being generated here. What is this? Are you getting my point? What is the size of 256? What is the size here? Let us try to understand it here. If I am trying to share, we cannot write it here. Yeah, you can write. So see this. We are worrying about this because we are just taking this SAR-256 again and again because of its security, and it is being used in the blockchain, and it is being used in the what? It is being used in the this Bitcoin. So what is the output? Let us call, we have a message of any length, kitna bhi bada message ho, but every time it is going to produce a 256 bit message. If you divide by 4, you will get 64. मतलब क्या है? 256 को 4 से, why did we divide it by 4? Because we are going to write every number into the hexadecimal value. This 4. 4 is what? 4. 4 किधर है? 4. 4 means what? In the 4 bit. I will write 4. 0, 1, 0, 0. Similarly, E. E means what? 14.
14.
Yeah. So, are you doing like that? So, in total, you have such 64 values, okay? And if you multiply it by 4, you are going to get 5.2 bit. So, taking the 5.2 bit for the example is very difficult actually. If you try to write whole bits here, okay, if you try to write whole bits here, it will be very difficult. So, to avoid this, what we did actually, we are going to take only 8 bit from here. 1, 2, 3, 4, 5, 6, 7, 8 bit. Okay? 8 bit here. So, you can see it here. 4E and something. So this is the processing. This is the processing actually. I'm copying this value here. 1 minute. Now I'm copying this value. So this is one thing. This is one thing. Now are you just imagine what it is? If I'm giving some message here, okay, any message, any long message, kitna bhi bada ho, paragraph or anything else. If I just click it, it is going to be appeared here. So what do you just guess it from here? Finding the hash value is very efficient. If I'm giving a message, it just produced. As soon as I presses this calculate hash value, the values are just appeared there. It means the computation of hash functions are very, very easy. This is the property of hash function. Okay. Now this is the hash function. What we did, we are going to choose the hashing. Hashing means what? We not need the 512 bits, we only need 8 digits here. So if you try to put it hash value 0 and calculate hash value, we are going to get the same 8 value, 8 digit value. So similarly, if you try to see, if you try to just modify it, 0, 1, 2, 2, you try to see it here, yes? So this is hello world 2, so we get this value. Okay. Now let us have, I just put 11 here. I'm going to get 70 something here. Let us call it 70C41, 70C41 at 11. 11 is not appeared here, no issue. Now, what is the challenge here? I'm telling that. Let us try to have some another example for hash puzzle. How the hash puzzle is here? What is my message? My message was hello world. Same thing will be appeared. Don't worry. My nonce is 0. My nonce is 0. Automatically it is going to concatenate these two values and going to get the same value whatever you have. Like 1, 0, 1, 2, every value. Let's call 6. Okay. Okay. Now let us call it 11 and like that. What I want to dictate basically here? What I want to dictate to you? What is the property I've seen here? What is the property I've seen here? If I'm going to take data, okay, only, and if I found the hash value, somebody can change the data as well as the hash value. But I don't want this type of things. because my message will be not secured. Whatever my information will be not secured. Not anybody actually, attackers can just modify this value. So to avoid this, we produced unknowns in such a manner that we will tell the, we will concatenate something. And if you are concatenating something, it is a hash puzzle. Hash puzzle, we have already seen that if you have a message, let us call if you have a message M, okay, if you concatenate something with this, okay, so we are going to find, let us call, we are going to find some value Z. So this M is given to you, M is known to you because M is already known to you because you can see the block. And this Z value is given to you. You cannot find this K value. You cannot find this K value. Are you following me? M is given to you, Z is given to you, this K is not going to be followed. So this data is here, the hash value is here, but you cannot find this knowns value. Now what is the restriction? I can say that you need to produce the known which is going to have leading zero. What I'm telling? Leading zero. How many zero? We will see it here. So if you try to found this type of things in this website, I'm saying that you found a leading zero solution, leading one solution means what? Means what? You solve this puzzle. I just want to try to solve this puzzle. The puzzle is being solved and we get 1 0 here. With what is the nonce value? Nonce value is 3. यही तो हैश पजल था मेरे भाई, यही तो हैश पजल था. What is the puzzle actually? Puzzle is that if you have a message M concatenated with K, that is a known, okay? If you try to find knowns, you cannot find. That is the hash puzzle. Okay? We solve it here. So this is for if you try to, if some attacker is trying to do this, what he will do? He knows the message, but he didn't know the hash function. He will start from the 0, again it try for the 1, again it try for the 3, 2, 3, 4, 5, 6. Let us call it, I need 2 leading 0. Need 2 leading 0. I get this output, this output. This data is with attacker, this hash value is with attacker, but he did not know the known. So this knowns creates some restriction, some power. It is 57. If attacker tries to know what is the knowns value, he at least do the brute force attack. What do you mean brute force attack? He is going to try every knowns 0, 1, 2, 3, 4, 5, 6, 7, dot, 57. If you try to do some little modification, if you try to have leading term, leading 0 as 3, and if you try to find what is the knowns value, it is 614. See it here. It is 614. 3 leading 0. Now if you try to increase the leading zeros to the 8, what will happen? Because we have all the zeros there. It will, I think, not work. It will not work because all will be 0. Hanged. 1 minute. I'm refreshing it. What was the problem? You know, it is not hanged. It is going to work, but it is going to take much time. Finding the leading 8 zeros, it is going to have the much time. Why it is hang kar raha hai. Okay? Why it is doing like this? Because let us see it again. Again it is the exit page. I am using the page. Again, what is the problem, mere bhai? What is the problem? This is the website. Okay. Hash puzzle. if you try to find leading 1 0, it will be appeared very, very soon. It is being happen here. If you move it 2, it is appeared. Move it 3, it is appeared. You have to put something here as well. Sorry. Again, we will run this algorithm. 1 leading 0. This one. Nonce is 3. 2 leading 0. Nonce is 52, 57. 3. Nonce is 614. क्या हो रहा है? This is a brute force attack. It is my algorithm is running 64 times. If you go to the 4, now my algorithm is going to have some time. What I'm telling, see this, I'm again doing this for 4. Now I just pressed it and I am waiting for it to be appear. So it is going to iterate for the 2,56,325 values. Since we have to start from the 0 and go up to this. If you go for the 5, if you go for the 5 leading 0, let us see it. After pressing it, I am waiting. Let us wait. Now it appeared. Now it is going, the knowns will be like 10 lakh something. So how difficult it is if I'm going to do, let us see for the 6, 7, 8. 6. I pressed it, I'm waiting. Waiting. Now it is being hanged because the number reaches 10 lakhs here. Now page in unresponsive. Why it is? Because the knowns number is very, very big here, and to compute the knowns, whatever program is being written, it is taking much time. That is the problem. So we did solve the problem. We simply solved the problem. What was the problem basically? The problem was that if I'm going to change my data as well as hash value, it is very simple. But if I use some knowns, now it has become a little bit actually difficult. So let us move further. Now detect tampering from hash pointer, that is hash chain. Now it is hash chain. What we are going to do, let us see it here. This is the actual hash chain in the blockchain. See, every this blocks is going to be divided into 2 parts. One is data part and another is block header. It is data or information or transaction, and this is block header. Let us call this is the data part. This is the data part, and it is being what? This data part is basically going to be computed like this. Hash of d I, whatever I is, and whatever hash value that is being called as message digest. क्या बोलते हैं इसको? This is being called as message digest. Okay, if you found hash of something, this is being stored in the next block, and there is a chain between these. Why it is? If I change something here, from D to D dash, if I put some from D to D dash I, okay, obviously I need to change it here. I need to change this hash value in the next block. See the complexity, what I'm trying to do. If I'm going to change it here, I need to change it here as well. Okay. Ready point? if I change it here, I need to change it here as well. Again the next block, again the next block. So this will be the complex. Because all are the linked together. All the hashes are linked together. Are you getting my point? All the links are basically linked together. You'll see in the next slide what is basically blockchain and all in that. For that, let the next thing is the miracle tree. Again, the miracle tree is being used to detect something. What it detects? See this. The hashes are organized in a hierarchical manner. We just seen the hashes. What is hierarchical hashing? Let us call. We have 4 transactions made. Some people has made 4 transactions being called as T1, T2, T3 and T4. Now they are going to compute the hash of T1 here and hash of T2 here, hash of T3 here, hash of T4 here. Okay. Now since there is 4 transactions, we can represent the transactions in 0, 0, 0, 1, 1, 0 and 1, 1. Add there is a 4 numbers, you can represent it by the 2-bit number, okay. So this is hash of 0, 0, hash of 0, 1, hash of 1, 0 and hash of 1, 1. Okay. Now what we are going to do, we concatenate these hashes. Now what we are going to do, we are going to have this type of things. Let us call it H00, concatenate या plus, whatever we have written 0, 1 and we are going to take hash of it. क्या है ये? This is the hierarchical hashing. We take this data, you find its hash. You take this data, you find its hash. Now you combine these 2 hashes, and now you find this hash, you are going to get H0. Similarly, on this side, this is the data, you find the hash of this data, you find the hash of this data, and you combine this, we are going to find the H1. From this 4, we reach it at 2. That's why we are going to H0 and H1. Okay. Now on the root level, since now it is 2, again we are going to add this one. This whatever we get H0 and whatever we get as H1, we are going to concatenate it and we are going to find its hash. So this is being called as H root. So this H root is being stored instead of this transaction. Are you following me? Are you following me? What is difficult to find? Let us for the attacker. Let us sum. You have 4 transactions, T1, T2, T3 and T4, and it is visible to everybody. So hash can be found very easily. You can find this hash very easily. Okay. But if you try to find this hash through the miracle tree, this is the miracle tree. क्या बोलते हैं इसको? Miracle tree. So it will be a little bit difficult. Okay, for finding we need to do some more. So this is a miracle tree. It is also being used in the blockchain. So this is the miracle root. No, this is the root node, root hash. Okay. This is the label 0. Let us write it here. Root level or level 0. Root level को बोलते हैं हमेशा level 0. This is the level 1. This is the level 2. And similarly level 3 will be also there. So this is the L1 means level 1, level 1. This is L2 means level 2, level 2, level 2 and level 2. So this is the miracle hash. We try to see it here. Now let us have this thing. Now see this blockchain at the hash chain. Okay. Previously we just seen this figure where my block is going to have a header part which is only having the hash of data and data. Now here in this block we are going to have many things like this previous hash will be there. Obviously, this is the previous hash we are having, and this is the block header only. There is no data. This is the block header. We are going to have this previous hash. We are going to have this block hash. Whatever the block hash is there, we are going to have knowns. We are going to have the Merkle tree. Means we are going to complicated my block header so that if there is change in any data, so its hash function is put on the next block cannot be edited. Okay. So for complicating the things, we have just doing all these things so that attacker cannot find it easily and the task of attacker is increased and it is computationally high. Now let us try to have some emphasis on concept of cryptography which is being used in blockchain. What is cryptography actually? What is cryptography? So if you talk about cryptography is nothing but secret writing. What I'm telling, it is secret writing. If you want to send some message to some of your friend and if the message is confidential, what you will do? You will hide this message and send it so that in between the communication, no attacker is able to see this message. So how we are doing this? We are doing this with encryption. With encryption. So basically we have two types of cryptography. One is being called as symmetric key cryptography and another is being called as asymmetric key cryptography. What I'm telling? Symmetric key cryptography and asymmetric key cryptography. Asymmetric key cryptography is sometimes also called as public key cryptography and asymmetric key cryptography is called as public key cryptography and symmetric key cryptography is sometimes called as secret cryptography or private key cryptography. It is also being called as private key cryptography. Private key cryptography. And it is asymmetric cryptography. Asymmetric key cryptography. What is different into these two cryptography? As the name suggests, symmetric means the same key is being used for encryption as well as decryption. What do you mean by this? If a person A sends some message to B, let us call he using some encryption method to encrypt M and after getting this encrypted message, what he will do, he will apply some decryption method so that he can get M. What it is? A want to send a message to B, he will encrypt this message. Why he is encrypting? So that in between the communication, there is a person C, he is just intercepting this communication and he is trying to take this EM from here. He will see EM and he will not understand what it is written because it is coded form. It is not the original message. So in symmetric cryptography, whatever key is being used to encrypt this message, okay, same key will be used for decryption. So for any communication between two persons, senders and receiver, the key is already existed with both. Otherwise, they cannot go with the communication. Are you getting my point? If you need a communication to be established, the key is with sender as well as a receiver. So the question is how to share this key. I'm sitting here and you are sitting somewhere else. If I want to send some message to you, I need to create a key first and then I will send the key to you. So the sending key is again a task. This key can be compromised. So this is the problem with the symmetric cryptography, and it is not going to address some requirement like it cannot authenticate anything. It can, but you need to do some lot of work for doing authentication and all and that. Now public key encryption is what? One key for encryption and one key for decryption. What are you telling? It was okay if there is only one key. What was the problem to sharing of the key? Public cryptographic tells that no, we don't use the same key here. Use K1 here for the encryption and K2 here for the decryption. Okay? What it is saying? You use K1 for the encryption and K2 for the decryption. If you are doing this type of thing, this K1 is going to be called as public key. K2 is private key. Means what? If I want to send a message to anybody, okay, anybody can use my public key. For example, if somebody is going to have your email ID, he can send you a message. But who can receive? Who is having the username and password of that ID? Anybody can encrypt the message in the public key, but the message can be decrypted only by the receiver, which is having the private key. So this key K1 and K2 belongs to a particular person, that is B. That is B. B hai na? B is the receiver. That is the receiver. If somebody wants to send some message to the receiver B, what he will do? He will pick his public key, which is available public key. Public key means public key is available publicly, but private key is kept secret with P. P will not share this private key. He is going to share only his or her public key so that anybody can send the message, or he only can or she only can decrypt the message with the K2. So basically blockchain is going to using the tool of cryptography as the public key cryptography. Public key cryptography is being basically used by this public blockchain. Now do you have any question? You can just ask if you have any.
In public key, both the transmitter and receiver is having of K1, sir, or K1 at one side and K2 on other side, sir.
Yeah, K1 is one side and K2 is another side. And but this K1 and K2 belongs to a person. Let us call I and you want to talk something or communicate some message. Okay. Let us call, I want to send the message to you. What I will do, I will use your public key. Okay. The key in the public cryptography comes in a pair. When there is a public key, its pair private key will be also there. If you are having two keys, let us call it public key and private key. I take your public key because it, as the name suggests, it is public key and it will be available in the public domain. So I will take your public key, let us call your email ID, and I will draft a message, I will send it to you. Now since you is only who is having the private key itself. So you will use that private key, let us call the password and username of your mail, okay? And you can just see the message, what the message is. That is the meaning. Okay.
Okay, thank you.
Anything else? Okay. Now,
Sir, one
Right.
doubt.
yeah.
So, like any message like which we have given is converted into some 256 length. So can I give like any numbers like characters, say some 1,000 characters like message?
Yes. Any message
no-
in the, sorry?
There is no limitation.
There is no limit on the message, but independent of the size of message, your hash value is going to be 256 bit. It is fixed.
Okay, okay.
If you are using SHA-256 algorithm, okay?
Hmm.
If you are
Yes,
going to use SHA-1 algorithm, it is going to produce 128 bit key.
Yes, sir.
Okay. Anything else? Now, let us try to understand.
Sir, one more doubt, sir.
पूछिए.
Sir, let's say suppose here we are doing hello world and you are getting some 8-digit code, sir.
Okay, correct.
So how to decrypt it, sir?
It is not
Let's
decrypted.
say I have
no.
code now in my hand.
Mhm.
I want to see hello world.
Let us try to discuss your part. You have
Yes,
a
sir.
hello word.
Yes, sir.
You have hello word. Okay, word explanatory mark. If you take its hash. Okay. Let
Yes,
us call
sir.
it M. ये has hello word को हमने M लिख दिया यहाँ पे. It is M. And you are going to get some code like 4, 3, A, B, okay, 9, 2, 0, 1. This is your code. It's visible or not visible?
Not visible.
किसी को नहीं दिख रहा है?
It is visible, sir.
Sir, visible.
No, sir.
How it's not?
Visible, sir, visible.
In the system, it is visible, sir. In the
Yes, sir.
computer.
Mobile, it is not visible, sir.
Kindly.
Mobile also visible, sir.
ठीक है.
Mobile also visible.
कोई बात नहीं. I'm writing it again. No issue. Let us. The question is that we have hello word as a message, and you need to take the hash of this message. Let us call M. It is going to produce HM value is, let us call 0, A, 9, 4, 5, B, C, D, E. This is my hash value. Now tell what you want to just know.
Sir, now I have hash value, right, sir?
Yeah.
With this, I want to recreate my original value. That means hello world I need, sir.
Oh, Baba, it's not possible. No, hash value is hash. Hash is what? Hash itself is a one-way function. We have already discussed it. It is a
Yes,
one-way
sir.
function. It
Okay.
is not in encryption type of thing. You cannot revert it. If you revert it, then there is no meaning. If you can revert it, then there is no meaning. Got my point?
Yes, sir.
So
Yes, sir.
this hash function basically is not an encryption algorithm. This is not a cryptographic, okay? This is not
Okay,
an encryption, you know. This is some function. And what is the encryption algorithm? This is other thing, okay? Where you are
Yes.
going to use two key, one for encryption, another for decryption. You
Yes.
are going to use one key for the encryption, and by using
Yes.
the decryption key, you can just recover the message. But here you
Okay.
are not going to use any key. No key is being used here.
Okay, sir. Okay, sir. Okay.
Okay.
Thank you.
Hello, sir.
Why we
Yes.
are using
Sir,
view?
along with the message, we are using the nonce.
Uh-huh.
Sir, for what purpose we are using the nonce? And after using the nonce also, we are using the restrictions.
Miracle tree. Miracle. No, restriction is
No,
that.
sir, restrictions.
Yeah,
So,
yeah,
what is the
yeah.
need of using the restrictions and hash?
Got your point. Got your point. 1 minute.
Hello, sir.
Yes, I'm here. Wait for some time.
Sir. Okay, sir. Are you getting?
Just
Are
yes,
you
yes.
getting?
Yeah, I got it. I just want to actually what is happened. I think something is being happened here. Nothing else. Yeah. So what I want to dictate to you. क्या हो गया? I just want to break it here. And I want to switch to the board. Yeah. So let us try to understand what is happening here. See this. If you have a message, if you create h of m and you put h of m somewhere else, I just put h of m somewhere else here. I put it here. Okay. Whenever there is a modification in m, whenever there is a modification of m in m, I can produce this h of m dash and I can compare this h of m dash with stored hm and we can see the difference. Since this m is changed to be m dash, ये इसको modify हो गया. This is being modified. Okay. Obviously, this hm and this hm dash will not equal. This is the property of hash function. It's two different functions, two different masses cannot have the same hash function. So this can be got. The user can got that there is a message mismatch, so I am not going to accept this message. Whatever the message is, it is being not accepted. But what if the attacker is going to change this m, along with this m, this hm is also being changed and being stored in the same place where this hm was stored. Now the authenticated user can just check, yeah, whatever message is coming, and its hash value is hm dash, and now it is matches with the stored hash value, which is also hm dash. So if attacker changed both the value m dash and hm dash, then no user can differentiate among the changes. He will just accept the wrong message. Okay, some person is telling like something, and if he's changing the message, wrong message, like let us think if somebody is trying to say I love you and somebody changes it to the I hate you, so everything will be spoiled. So to avoid this situation, what we did, we just try unknown's value along with this data value, message value. And we are going to store this value now. This value is being stored. Whenever you have this m value, okay, you just choose a knowns. So the message will be automatically known to the attacker. This value is automatically known to the attacker, but attacker does not know what is knowns. Who knows this knowns? Only you. So if attacker tries to know what is knowns, there is some restrictions. I have shown that. In the hash functions, I put first as the zero value, first digit as zero. Let us call sec 2 digits as zero, first leading 2 digits, 3 digit as zero, 4 digit as zero, means at how much iteration I can get this first digit, this second digit, this third digit, this fourth digit, like that. What we've seen, at the third iteration, when we started from 0, 1, 2, 3, I get that the first 0 is appeared. But for this 20 leading 20, I need to iterate for 514 times. Means attacker need to be gone for 514 bit. Now similarly for this 3 something is here, 4 something is here. At reaching 6 at the 60 leading 60, what we see, it is in 10 lakhs. It is in 10 lakhs. So my machine is now hanging at this point. So attacker's machine is also hanging. So for finding, let us call, I just put I'm a restriction that the knowns is selected in such a manner that first 8 bits are 0. So for finding these knowns for the attacker is difficult. But if I am the genuine user and I just want to put my value, I can find it. What is the size of message? I don't know. I don't care about it. And what is the size of knowns? I also don't care about it. What is the size of these knowns? Like 10 lakh, 50 lakh, in millions, in billions. I'm not going to worry because I need to take only hash, and hash is basically easy to compute. That's why it is efficient. So in this manner, this restriction or introducing the knowns secures our message. Okay? Got the point or anything else?
Sir, ourselves we keep the restrictions.
Mm-hmm. Sorry, again, repeat.
My question is, we are the people, we keep the restrictions.
Okay.
That is
Yeah,
my
we are the
question,
people.
sir.
Yeah. The user who is going to store the data, okay, is the person who create the restriction. Ki how many leading 0 you want
Okay, sir. Okay.
to safeguard of my data only.
With keep on changing the restrictions, the nonce value also keep on changes.
Yeah, obviously it will be keep on changing.
Okay, sir.
So why knowns? The main question is that why knowns? The knowns is for securing my data from the attacker. Okay. If I'm going to use, if I'm going to use a large value of, tell.
And one more question, sir. For keeping the more secure, will you maintain the more zeros in leading position?
Yeah, obviously. If you increase the number of 0 in the leading position, the n value, the knowns value will be increased. It is being increased from 3 from a single 0 to 514 for the 20, and in 10 lakh in that 60. You can see the increment in the n. What is this 10 lakh? This is the value of n. So if you take a big n, okay, it will secure your data much. Okay.
Okay, sir. Okay. Thank you, sir.
Okay. Anything else?
Sir, then what about the receiver? Say suppose you are sending a message with
No,
lot
there
of...
is no receiver. No, there is no receiver, no.
This is only transaction, that's it.
This is, see this, don't be confused. Here there is no receiver. This is
Just
my
you are writing.
data.
That's it.
Yeah, I'm putting some data so that nobody can just change my data. Let us call, I have a hard drive, okay.
Yes,
I have a hard drive in my computer, okay. I put a lot of data there. What I did, I take the hash of this raw data, and since this hash value is very small, let us call 512 bit or 256 bit, I put that number into somewhere else. Let us call it cloud and Google Cloud. Okay. If I in future, after 10 years, let us call after 10 years, I am in doubt that is this data is correct or not, or somebody has changed the data. What I will do? I will again take the same hash function on that data, and I will match calculated hash value with the stored hash value. And if both are same, I can just get it. Yeah, there is no change in the data. Got this point?
Yes.
Okay. Anything else?
Sir, in the nonsense value, if we are going to keeping eight zeros.
Yeah.
So that means, but initially we are taking in the hashing value only 8 values. That means all are going to be 0, sir.
Yeah, all are not actually. For the simplicity, we have changed our 64 digits into the 8 digits. Total digits are how much? In SHA 5, SHA 256. Total number of bits produced is 256 bit. Okay. Now I have changed this 256 bit into the hexadecimal value. Now it is giving 64 digits. Okay. For sake of simplicity, I have taken only 8 digits. However, it is 64 digits. Getting a point?
Yes, sir.
Okay. So if you want to continue this one, okay, like 90, 10, 11, it will also work. It is going to increase the complexity of your program, complexity of your whatever data you have stored there.
Okay.
Okay.
Sir,
Yeah.
that means the actual hash in 256 bits. Is it right? But for understanding, we are just only taking the starting 8 bits.
Yeah, starting 8, not 8 bit. 8 bit means 32 bit. Are you getting? 8 bit means 8 into 4, 32 bits.
Okay, sir. Starting eight numbers. Starting 8 numbers only we are taking.
Yeah.
Just for
From the
simplicity.
from the hexadecimal value, you are taking the 8 values. Okay. If you change it in the bits, it will be 32 bit.
Okay, sir. Okay.
Okay. Anything else? Okay. So we are aborting this class for today here. Okay.
Sir, last question, sir. Sorry to
Yeah.
disturb you.
Oh, no,
We
no, no
never
issue.
Sir, we never use 250 values, sir. 256 values. We use only 8 values, sir.
No,
The
no, no, no,
hashes.
no. No, 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 no. Actually, we are using 256 bits. Okay. Not
Yes.
8 bits. For the teaching purpose, so that writing this 8 bits, okay, 8 digits is simpler into the slides. Okay, if I will write a very long number, okay, the slides will be very lengthy.
For simplicity, we are taking the first 8
Yeah,
digits.
yeah. For just for the simplicity, see this. See
Okay.
this. For the simplicity, if I will put a very long number here, so it will be like this. Okay,
For
and
suppose
yeah.
the
Tell.
initial message is matching. If I have the two messages, sir, hello world or hello India. Here initially the two words are matching. There may be a chance of getting of equal hashing the first 8 digits.
No. This is the property of, yeah, I'm explaining it. This is the property of hash function. There is a effect that is being called as avalanche effect. I have just dictated when you are at the campus. This is avalanche effect. What avalanche effect tells basically? Avalanche effect. If you change one bit in the message, what I'm telling, if you change one bit in the message, there is change in every bit in the hash value. Getting the point?
Yes, yes, sir.
Many, not every, basically many bits in the means changing one bit in the message will lead to change many bits in the output.
Yes, sir.
So
Yes, sir.
if you do like this, it will not occur every time. Okay. Any more question?
Sir, suppose I am one user and you are another user. Say suppose we are sending same message, hello world, hello world. So the same like 256.
No. Why we are going to send this hash function? Actually, this is not encryption. We are having this hash function. Okay. If two persons, two different people is going to send me the hash value, that is another case. If hello world is being generated, yeah, he will send the same message. Another person is also going to have the hello world. Yes, it is being sent the same message. Because the hashes are always being calculated the same for the similar type of messages.
Okay. Okay.
Okay then. So let us stop for today. Thank you very much.